Hello students, now in today's lecture we are going to discuss a new topic, that is simple machine. So in that we have to discuss the several terms. That one is started from the first point, that is what do you mean by machine. So it is very simple. Machine is a device which is used to perform a certain defined task, or we can say certain prescribed task. Or in a simple language we can say that machine is a device which is useful to perform some work. So it is nothing but a simple machine. Now next, you must know about the lifting machine. What do you mean by lifting machine? So word itself, that is lifting, say that is a device which is used to lift a certain load. It is known as lifting machine. Now next, what do you mean by, what is the classification of machine? Okay, so basically machine can be classified into two types. That is, first one is the simple machine and another one is the compound machine. So see, first of all we discuss machine, then lifting machine. So in this chapter, whatever the machine we have to discuss, their basic function is to lift a certain load by applying a certain effort, by applying a certain energy. Is it right? Because simple example is there. If I am here, if I have to lift a certain load, so for lifting that load I have to apply a certain effort, certain energy. So whatever the energy is applied, that is nothing but an effort, and whatever the load is to be lifted, it is nothing but a simple load. Okay, now so on the basis of that, there are two types of machine. First one is the simple machine and another one is the compound machine. So what do you mean by simple machine? A machine which has only one point to only one point for the application of effort and only one point for the load which is to be lifted. That means it is that machine which has only one point for the application of effort and for the load is to be lifted. So in simple language we can say that it involves only one mechanism. Only one mechanism, because this machine has only one point for performing a certain operation. That means if we have to lift a load, for that lifting it has only one point. We have to apply a certain effort for lifting the load, so for that operation also it has only point. So whenever there is a single point for the application of effort and single point for the load which is to be lifted, is known as simple machine. Now next one is the compound machine. So see, the machine which has more than one point for the application of load and more than one point for the load which is to be lifted is known as compound machine. Or in simple language we can say that compound machine involves different numbers of simple machine, because it involves numbers of mechanism. Means we can say that there are numbers of point for lifting a load or numbers of point for applying the effort. Okay, so it consists of number of mechanism. So it consists of numbers of simple machine. The simple example of compound machine, we can take the lathe machine, where we can perform the several operations. So that one is the simple example of compound machine. Now next we have to discuss what is load and what is effort. I already told you what is load. A weight is to be lifted is known as load. Whatever the weight we have to lift, that is known as load, which is denoted by W. Okay, and what is effort? The force with which load is lifted is known as effort, and generally that effort is denoted by P, capital P. So load is simple, the weight is to be lifted is known as load, and the force with which the load is lifted is known as effort. Now next, what is mechanical advantage? Yes, because you know that our subject is totally design subject, design based subject. Here we are going to discuss the very simple term related with the design. If we have to design any machine, then what terms we must consider while designing, that only we are going to discuss from the basic subject, that is applied mechanics. So next one is the mechanical advantage. So it is very simple. It is defined as the ratio of load lifted to the effort applied. Is it? So that mechanical advantage can be denoted by MA, that is MA is equal to W upon P, and it has no unit. Why? Because load is also measured in Newton, effort is also measured in Newton, so Newton will get cancelled, so it has no unit. So it is very simple. Mechanical advantage is defined as the ratio of load lifted to the effort applied. That means from this term we can calculate, that is how much that machine is efficient, or how much exactly effort is required to lift the load, or how much load is lifted by applying a certain effort. That tells us the mechanical advantage. Yes. Now next is velocity ratio. Yes, after mechanical advantage we are going to discuss the velocity ratio. What is velocity ratio? It is defined as the ratio of distance traveled by effort to the distance traveled by load. Okay, yes, because whenever we are going to analyze any machine, so you must know that is definitely if certain machine is used to lift a certain load by applying a certain effort, that means it has 2 points, it has 2 pan, it has 2 components. On one pan the load will be lifted, and from the another component, that is, or another pan, the effort is applied. So whenever there is a certain application of effort or certain lifting of load, so that 2 points will move. So for analyzing that motion, for analyzing that mechanism, there is a one term, that is velocity ratio, because whenever the machine will perform a certain task, their components will move. So how much that exactly moved, or how much work has been done by that machine. So for calculating that, velocity ratio term is very important. So velocity ratio is defined as the ratio of distance traveled by effort to the distance traveled by load. And yes, again there are both the distance. So distance, the unit of both the terms, that is same, either in centimeter, meter, mm. So both that unit will cancel. So again that velocity ratio has no unit. Yes, next is the efficiency, a very important term, because whenever we are going to analyze any function, any machine, any force, any component, so we must know about the efficiency, how much that machine is efficient. Okay, that you must know about you must know about that things, that is efficiency. Okay, because if I am here, I am giving you 100% and you are taking 90%, that means you are 90% efficient. If I am giving a certain output 100% and I am getting input 100% and I am getting a output 90%, that means that machine efficiency is 90%. Okay, so that in generalize, the efficiency can be calculated, that is output upon input. Efficiency is denoted by eta. So eta is equal to output upon input. It can be calculated in terms of percentage, so multiplied by 100. Now in this unit, that is in simple machine, so output will be treated as mechanical advantage and input is nothing but the velocity ratio. That means motion of that point where load is lifted and effort is applied. So while solving the numericals on simple machine, whenever they will ask to calculate the efficiency, so efficiency can be calculated by using the formula eta is equal to, or efficiency is equal to, mechanical advantage MA divided by velocity ratio into 100. In generalize, it can be calculated output upon input. Now next is, that is ideal load and ideal effort. What do you mean by ideal load, or what do you mean by ideal effort? See, initially we discussed that is load and effort. That one is the actual. Actual means whatever the load is lifted or whatever the effort is applied, that is the actual. Then what do you mean by ideal? So ideal load is nothing but the load without friction. Where there is no friction, that is known as ideal load. When there is no friction in effort, then it is known as ideal effort, because you know that when in actual we perform a certain work, then definitely there is a certain friction. So because of that, certain energy can be wasted. Okay, so certain force may be wasted, certain effort may be wasted. That is because of only friction. Okay, so in details we will discuss the friction in later chapter, in later on, because we have a one chapter that is only friction. So right now, ideal load means what? The load without friction is known as ideal load, which can be calculated by using the formula, that is Wi, I suffix which stands for ideal. So Wi is equal to P into Vr, and ideal effort, the effort without friction, is known as ideal effort, which is denoted by Pi. So Pi can be calculated by formula, that is W upon Vr. Next is, that is load lost in friction and effort lost in friction. You know that we already discussed the actual load. Actual load means what? That is the load with friction. And ideal means what? That is load without friction. Is it right? So definitely I already told, if there is without friction, that means there is no any lost in load. If there is a friction, then there is certain losses. So how much exactly load lost in friction and effort lost in friction? So that can be calculated, because we have both the terms, that is actual load and load lost in friction. So if we have to calculate how much load is lost, so that can be calculated by the their difference, or so that we can say that load lost in friction is defined as the algebraic difference of that is ideal load and the actual load. So it can be calculated, Wf is equal to Wi minus W, that is ideal load minus actual load. And that ideal load, you know that we already discussed, ideal load can be calculated by using the formula P into Vr minus W. And next is effort lost in friction. In similar way, we have to calculate effort lost in friction. So it can be calculated by the algebraic difference of that is nothing but the P minus Pi. So F stand for friction, it is nothing but a suffix for that P. So Pf is equal to P minus Pi. So P minus Pi we already calculated, W upon Vr. Yes, we discussed, that is ideal load, actual load, load lost in friction, effort lost in friction. So whatever the term is, whatever the things is there, that is load lost in friction, effort lost in friction, ideal load, that is load without friction, ideal effort, load with effort without friction. Okay, so all these are the load and effort, and that can be measured in only Newton. Yes, and last terms in this unit, that is nothing but the law of machine. Law of machine tells us, that is how much, from that equation of law of machine we can calculate the how much effort is applied for lifting a certain load, or how much load can be lifted by applying a certain effort. If you will know about any quantity, either effort or load, so we can calculate the other terms, that is if effort is known, then we can calculate load. If load is known, we can calculate effort for a specific machine. Okay, so law of machine is, question may be asked, that is define law of machine, or what is law of machine? So law of machine is the relation between load and effort with slope and y-intercept. So slope is denoted by m and y-intercept is nothing but the c. So you can see on the board, I already plotted a one simple graph. If we have to make a relation between load and effort, so I have simply plotted there one graph. So see here, whenever we have a certain values of load, say we can W1, W2, W3, and if we have a certain values of effort P1, P2, P3, so we will plot one graph, that is load on the x-axis and effort on the y-axis. So we will get a certain points. Whenever that point we will join by a straight line, so that when that straight line will intersect the y-axis, the point at which that straight line intersect, so the distance from that section point up to the horizontal axis is nothing but the C, that is y intercept. So it is very simple. So law of motion, and whatever the slope that inclined line or straight line having, that is m slope. Okay, so while solving the numerical, we will discuss that all the things in detail. So simply you must know about the law of motion. So law of motion is the relation between load and effort with slope and y intercept. Y intercept is what? The distance from the horizontal axis up to the point of intersection in between y axis and the straight line which joined all the effort load point on the graph. Yes, so this is all about the basic concept of simple machine. Now from next lecture we are going to discuss the actual numericals, how to calculate the simple terms. Thank you.